Hi friends, today we are going to discuss about this reflection of light by curved surfaces or curved mirrors. So curved surfaces is nothing but reflection of light. Each and every light is a ray consisting of a, so surfaces will be different. This means plane surfaces will be there, and as well as so curved surfaces are there, and the lenses will also be present. So now today we are going to discuss about the mirrors. Okay, now the reflection of light. In our nature, we can see that each and every object we can see with the reflection of light only. Without reflection of light, we cannot see the object. So because once you observe that sun rays are coming from the universe, so then it is right to fall on object. Then again it will reflect and coming near to our eyes, then only we can see the object. Otherwise we cannot see the object. So we already know that. So that's why now is the starting of the reflection of light. So we have the different type of curved mirrors are there. So basically what kind of curved mirrors are there? First of all I am going to discuss. The first one is a concave mirror. Okay, actually mirror is nothing but only one surface has to work. The other surface is not work, is covered with the other materials. Is nothing but it is a mirror. Now concave mirror I'll show you. Just once you observe that concave mirror is there, then so this is a one. So curved surfaces. Do you already know that this is a curved surface? It is not a mirror because only one surface has to work. Then what I said that this is, so when I am going to draw these lines, so this is called as a, now back side these lines will indicate that this is not using the area, only this area should be used. So that's why it is a concave. Simple logic, how to remember the concave and concave mirror. Convex mirrors is nothing but concave mirror, how to remember? Simple. The caves are there, you know already caves. The caves are just inside the path only, inside the way only we can observe the caves, right? The outside the way we cannot mix, outside back side of the cave we cannot do that. So that's why inside part we can so use, that is called as a concave mirror. Now one more is will be there. So it is a convex. So convex mirror. Now what does it mean? Convex mirror is nothing but convex mirror is a different. Is nothing but the back side part should be used. That is called as a convex mirror. So what does it mean? Once observe, you say here. So I am going to just draw like this. Here once you observe the concave, convex. So here the inside part is just with dots, means nothing but it is not using area. So this is a convex surface. This is a convex mirror. This is a concave and this is a convex mirrors. Now we will go for the convex and concave. You already know that we got it. So we have to discuss about this, what kind of the, which is a convergent and which is a divergent. Okay, I will say one thing to you, convergent and divergent. Convergent is nothing but when all rays of light is coming closer, is nothing but is a convergent. Convergent is nothing but all rays are coming closer. Different type of rays are coming closer, then it is a convergent. And divergence is nothing but after reflection or whatever may be. So after reflection, for example, after reflection all rays will diverge, means it will go all directions, is not coming closer, that is called as a divergent. All rays will go in all directions, is not having so specific direction or not coming to the one point, all directions it will go, it is called as a divergent. Now so for this one activity is there, you can do one activity, you can take in one rubber foam or anything. Just for example, you can take this is a rubber foam, right? Any rubber or duster or anything, right? So you can see these things. So this is a, once you attach three pins perpendicular to the surface area, for example, these so pins are there. So three pins are arranged so perpendicular to the surface of this foam. Then first condition, first you can do one thing, you can bend like this. curved inwards. Just for example, this is a foam. You can just curve like this. Then automatically, what it will be look like? It should be look like this one. Then what about these three pins are there? Means these three pins are ready to appear like this. So what we observe from this, all are coming together. It look like a coming together. Is what I said that. So convergent is nothing but all rays should come closer. So then it is said to be a concave mirror only. So that's why what we conclude, concave mirror is a convergent mirror. Concave mirror is a convergent mirror. Okay. In another way, just one more. So same foam will be there. Again, now I am going to just do like this. Okay. So then when I am going to say this is a foam, you can see that if you bend like this, this part is useful. Now I am going to just bend like this. Then you can see that these directions will be in a different. So different directions will be present. Then what we conclude from this? So this is a plane surfaces, and that too it is a. So once you see that back side, this part is not useful. That's why. So what is that? Concave. So concave mirror is a convergent. And here what it will be using that the bulged part outside. The bulged part is a. So divergent. It is a convex. Is a divergent. Okay. So that's why we can say that concave mirror is a convergent. Convex. So mirror is a divergent. So first of all, okay, concave and convex. So here the concave perfect definition is a just curved inwards, and the divergent is nothing but convex mirror is nothing but bulged outwards. Take a simple example, spoon example is the best one. Okay, so take a spoon. For example, the spoon. So backside, once you observe that backside part is a convex. So inside part is a concave, convex and concave. So we can easy to identify. Now which one is a concave, which one is a convergent is nothing but concave is a convergent and divergent is a convex. Then next we will go for the ray diagrams. So ray diagrams are very important because in our 10th class, especially those who are ready to appear to the 10th class examinations, they must follow this ray diagrams and rules and regulations. If you are unable to follow rules and regulation of this ray diagrams, we cannot draw proper ray diagrams. In a reflection of light by curved surfaces is definitely depending on your ray diagrams only. Before going to draw a ray diagrams, first of all I am going to discuss about that. What is that? So things are there. So information will be there. For example, now it is a curved surfaces. Now I am going to just draw horizontal line. So now it should be backside part I am going to cover is nothing but it is a concave mirror. Now this is a concave mirror. Now I said that this is a one horizontal line. What is a horizontal line is nothing but it is a principal axis. So principal axis. So what is mean by principal axis is nothing but the principal axis is a one imaginary line. It divides the two equal parts of a curvature. The principal axis is a imaginary line. It divides two equal parts of a curvature. This is called as a principal axis. Okay. Now, so what I said that this is a principal axis completed. Now one more is there. This is called as a pole. Now this point. What is the meaning of the pole means? Where the principal axis will meet on a curvature, either concave or convex, whatever. Where the principal axis will meet on a curvature, the meeting point is called as a pole. So meeting point is called as a pole. The next one. So one more word is there, that is a center of curvature. You already know center point. So for that, I am going to say one example to you. So here, once I am going to show one example. Everyone knows that So center of the circle, according to your mathematics, so center of the circle will be present. For example, it is a circle. Now you can see that this is the center point will be there. This is a center. Okay, now this is center of this circle. If you just cut these into two equal parts, once you say to me, for example, when I am going to cut these two equal parts, then one part is just reduced. The remaining part will be there. That's why it's a curvature or not. This is a curvature. That center point is as it is. Now what I said that this center point is called as center of curvature, either concave or convex. Okay. So this curvature contains one center point. That point is called as a center of curvature. From this center of curvature, we can draw more imaginary lines. It's nothing but it is all our normals. So what we call these all are normal. So normals is a perpendicular to the curvature. If I am going to take this is a perpendicular area, this is a surface area perpendicular, this is a surface area, then is a perpendicular, this is a surface area, it is a perpendicular. Everywhere where the perpendicular lines will be there from the curvature, that should be meet on a center of curvature. So that is a normals. Now we will go for the another word. It is a focal point. What is mean by focal point? It's a focus. For example, in general language, we already know that generalized things will be there. What does it mean? Focus. I am going to focus on one object. I am going to focus on studies. I am going to focus on you. So these things will be there. Na? So this all are is nothing but focus. Means all rays will meet. That is called as a focus in this ray diagrams. Now I am going to show that. For example, so it is a curvature. Again I am going to draw. So here it should be, for example, it should be, so yes, this is a concave. So mirror. Now you already know that this is a principal axis. This is a dot, is a pole. Then if any ray is coming from infinity, we don't know where it is coming from, right? So ray is coming from infinity. After reflection, everything is right to reflect by a curved surfaces also. Okay, not only plane surfaces, curved surfaces also reflection will be there. So where that rays will meet on a principal axis. So where the rays will meet on a principal axis is called as a focal point. Focal point means all rays. For example, one more ray I am going to consider. Then it is also just coming from infinity. Then again after reflection, then it should be ready to meet on a principal axis. The meeting point is called as a focal point. Focal point. So then from this we already know that this is a pole. Pole will be there and the focal point is there. The distance between focal point to pole is nothing but it is a focal length. That should be shown with a small f. So capital F is nothing but focal point. So small f is called as a focal length. Now this is a focal point, this is a focal length. From the distance between focal point to pole is called as a focal length. Then next one more is also there. That should be the center of curvature. So we already know, just now we discussed about the center of curvature. What is the center of curvature is nothing but, for example, so here the distance between the pole to center point. The distance between pole to center point is called as the radius of curvature. It should be shown with a capital R. It should be shown with a capital R. So I will say that R is equals to radius of curvature is equals to, so 2 into F. 2 into F is nothing but small f. F is focal length, is nothing but simply we can say that it is a double. The focal lengths are double. So that's why radius of curvature R is equals to 2 into F, or otherwise F is equals to R by 2. Sometimes in a problems we can use this kind of formulas. So then only we will solve this some example problems, right? So now we'll go for the another one. So we have a radius of curvature and principal axis and everything will be there. So here the convergent and divergent mirrors are there. Every time convergent mirrors are trying to make images. So divergent mirrors are not giving a sharp images. We have the different type of things are there. Now, so before going to enter into one more ray diagrams, we can discuss about the one more important points are there. What are the few important points I will say? For example, real images. So real images. For example, I will say to you real and so real images is nothing but real will be there and virtual will be there. So what is called as a virtual image? So what is the difference between these two? What is the meaning of the real images and so virtual images? So according to our generalized words, real images is nothing but practically, really, real time it will appear. So virtual is nothing but imaginary. We cannot catch on a screen. Simple logic. So which image can be catch on screen is called as a real image. Which cannot be catch on a screen is called as a virtual image. Which can be catch, which cannot be catch on screen. Simple example I will say to you. For example, I want to take a photograph. So if now I am going to take a photograph of myself, then it is nice. Now I use different type of clothes. Then if by tomorrow, when I am going to see, I just observe same as it is how I am now. So as it is, after a long time, after 1 year, 2 years, 3 years also, 10 years also, I will be like this only because it is a already captured on a camera, on this photograph. For the photograph, that's why it's a real image now. But virtual images are there. Virtual images means, for example, now I am a person, I want to stand in front of a camera. Then I can see myself. Okay, right. After 10 minutes, again I will come and I will see. May or may not, I am going to change myself. So I am going to remove my spectacles, or I am going to use so different type of clothes or anything. So that's why the changes may appear, but the previous one is not appeared. That is called as a virtual images. That is a not confirmed. It's nothing but not captured. So this can be real images will be captured. So that is a real and so virtual images. One more things are also there. Few things are there. Now, what does it means? Diminished. So diminished. So what is meant by diminished? And one more is there. Diminished and so enlarged. So what is the things are there? Diminished and enlarged. So diminished is nothing but the object size and image size. Okay, both will be there. The sizes are there. The image size is less than the object size. It's nothing but mere small objects. For example, so object will be there. Object like this. See. So for example, this is an object. You can feel this is an object. Then image will be there. So image, this much of size, is nothing but what I said compared to the object. So image should be smaller. Compared to the object, image should be smaller. That is called as a diminished. Diminished. Okay, this is suitable for the see object and image. This example is suitable for the diminished. It is nothing but so image size should be less than the object size. Then we go for the another one is the enlarged. Now when go for the enlarged means simple, in the name only there it will be enlarged means extensible. For example, now the object size is somewhat okay, little bit some height, then the size of the image should be more than the object. The size of the image more than the object is called as a enlarged images. These are the enlarged images. And next one, so one more word is also there. It is saying inverted. Inverted means every time the object, for example, if I am going to see a, did you know that pinhole camera, if you observe with a pinhole camera, each and every object will be shown as a reverse. For example, when I use this one, arrow is a upward direction object. Then if you observe that image, it will be appear the reverse. It's nothing but what we call that inverted image. It's a totally, it is a reverse, means inverted images, then up arrow and down arrow. So what it? So this is called as a inverted images. We have to get a sharp images also there. Sharp images means where we will get a clear picture. Clear. So same object. Okay, how the object will be the same as the sharp images will be present. So that is a one more thing will be there. Then we'll go for the another topic. So that it should be so making of your ray diagrams. What condition wise ray diagrams will be there, and before that condition wise ray diagrams, one more thing will be there, that is the rules and sign conventions. So in our 10th class, especially the reflection of light by curved surfaces or curved mirrors will be there. So in this chapter, that rules and sign conventions are important. Without knowing rules and without knowing sign conventions, we cannot draw any ray diagram. So first of all we can learn. So now you see that. Okay, see here there is a now first rule will be there. So rule 1. So to draw a ray diagram. So what is the rule 1? I will say that if any ray is coming from infinity, is nothing but undefined area. Where it is coming from, we don't know. If any ray is coming from infinity, then parallel to the principal axis. I will show that ray diagram. Once you see here, this is a concave, so mirror, and principal axis is there. Okay, so this is a principal axis, concave mirror will be there. So here the concave mirror, if any ray is coming from infinity, we don't know where it is coming from, only one ray will be there, that is A. So coming from infinity, you just imagine, if any ray is coming from infinity, after reflection from the curvature, is nothing but after reflection from a concave or convex surface, the ray will pass through the focal point. Okay, if any ray is coming from infinity parallel to the principal axis, then after reflection the ray pass through the focal point is called as a first rule. It is a first rule. Then next one, rule second will be there, it's the same, so vice versa, it's nothing but so small changes will be there. If now previously what I said, the ray is coming from infinity, after reflection it passed through a focal point, but now what will we say that if any ray is passing through the focal point, if any ray is passing through the focal point, after reflection the ray goes to infinity and parallel to the principal axis. Ray goes to infinity and parallel to the principal axis. This is called as a rule 2. Then next another one will be there. So what it will be there? Another one, rule 3. So rule 3 is some small changes, and so these two are related, but the third one is not related to these two rules. Then once you observe that, if you see rule 3, if any ray is passing through the center of curvature, for example, so it is a center of curvature, you can think it is a center of curvature. If any ray is just passing through the center of curvature, after reflection also the ray passed through the center of curvature, is nothing but that incident ray and reflected ray. Incident ray is nothing but where it will fall. So which ray will fall? There is an incident ray, and after reflection the ray passed through the center of curvature again, means the same path it will acquire. So that is called as a rule 3. So what it now? So now it is if any ray is coming from passing through the center of curvature, after reflection ray pass through the center of curvature, means so same path in a reverse direction pass. So then it is called as a third rule. Now fourth rule will also be present. That fourth rule will be, if any ray, for example, I'll say to you, for example, we already know that first law of reflection. Angle of incidence is equals to angle of reflection will be there. For example, rule 4. Now what is the rule 4 is nothing but, for example, you can just think that this is a concave. Again I am going to draw concave surface. Then here the concave surface will be there. Okay, so if any ray is ready to incident on pole, so this is a pole now. So if any ray is ready to incident on pole, the same angle of incidence it should be reflect, means how much of incident angle should be present, the same angle it should be reflect. Angle of incidence is equals to angle of reflection, that is angle I is equals to angle R. This is called as a rule 4. And then we'll go for the sign conventions. Sign conventions will be present. So sign conventions is very important, because which one is taken as a positive, which one is taken as a negative, everything we can do with the sign conventions only. Before that, I'll ask one question. Just you can see here, when I am going to say this is a concave mirror, this is a concave mirror. In this concave mirror, this is a pole, we already know that. Okay, and the center of curvature will be present, and the focal point will also present. Everything will be there, right? For example, simple example, I will show that. If any just ray, just keep an object somewhere. Just I will show that. For example, I am going to keep an object. Then here is a one ray. I am going to consider one more ray. Yes, this ray is ready to pass through the focal point. So this ray is ready to pass through the okay. Now you can see here. For example, it's a series here. Now that meeting point. So this is you can feel that it is a object and object, and this is the image. You can see here. From the object to is nothing but pole to object, PO. P. Now PO is nothing but U. What it will show that U is nothing but object distance. Object distance. Then what about the P, and here it is an I. You can feel that it is an I. So P to I is a image distance, is nothing but V. Image distance. So PO is a object distance, PI is a image distance. Then here the PO and PI. So now what we say that O and it is a this is a U and this is a V. Object distance, image distance. We already know that the focal length is a small f and radius of curvature is a r. Now the conditions I am going to say, that sign convention conditions. Okay. Now sign convention conditions will be there. That sign conventions conditions means first condition, all the rays should calculate from the pole. All the distances should be calculated from the pole. All distances, for example, you just see that this is a concave surface. Then once you observe concave mirror, okay, every time you can see that this is a P is a pole. All the distances, whatever the object distance, image distance, the focal length, the radius of curvature, everything, all distance will ready to measure from the pole only. From the pole. That's the first condition, first rule. And second rule will be go for the incident ray direction is a positive. The remaining all directions are negative. Incident ray direction is a positive. The remaining all directions are negative. Simple example I will show that. For example, say concave. Just you can see that concave mirror. Okay, what I said that incident ray direction is a positive. For example, this is a ray. Now I started, then it should be passing through a focal point, then another ray is also there. Just you can see that this is the making of image. So now you say that incident ray, what is it? PO and PI. So it should be, now PO is nothing but object distance. Now we say to me, PO is a positive or negative? So according to that, what I said, incident ray direction, incident ray direction will be like this. That should be positive. The remaining all are negative. That's why incident ray direction. Now, what is the first condition? All the distances will measure from the pole only. But we can start from here. The measurement will start from here, but direction is opposite direction. That's why we cannot take it easy. PO is a minus U only. Incident ray direction is a positive, but we are not taking incident ray direction wise. From the pole only we calculate. That's why it is a minus U. The remaining all directions negative only, except that incident ray direction. Then what is the PI? So PI also we can start from the measurement from the pole only. That's why minus V. And PF, pole to focal point, is also minus F. So these are the things will be there. PO is minus U, PI is a minus V, PF is also minus F. Everything should be negative. Okay. So these are the basic things what we have.